Alright, this will be the examples by using the application of implicit differentiation. So that's we have to find the gradient of the curve at this point here. Usually when they said find the gradient of the curve at this point, is referred to the gradient of the tangent. So it means that the gradient here is the value, right? The gradient is the value of dy dx. You have to understand the value of dy dx at this point, the x2 and y -1. So for this curve, so as you know that dy dx, right? So you have to differentiate this whole thing with respect to x to get the dy dx. So that's the idea of doing this question. So of course you need to have a knowledge of applying the implicit differentiation for a implicit function, right? So okay, I'm going to differentiate this whole thing with respect to x. So differentiate 2x squared, you will have 4x, right? You ddx for 2x squared, you will have 4x. Differentiate y squared, you will have 2y dy dx, right? And for this, of course, you see there is a product between 2x and y. So you need to apply product rule. As you see that this is a product between 2x and y. So you apply uv. So plus with, so I put a bracket here to apply the uv prime plus with vu prime. So u 2x, v prime, so dy dx plus with v y, differentiate 2x, you have 2, right? Of course, you're differentiating the 5, you're getting 0, right? It's a constant. So right now you have done differentiating here. So for this case, you have no need to, yes, in the previous video I have teach you to dy dx, you arrange the dy dx such that in terms of x and y, but this case you need to evaluate dy dx, right? So you don't need to waste your time here to rearranging everything. So because that you know that you just need to find the value of dy dx, right? So then you look at here, you have given the value of x and y, right? X and y. So you just plug into the equation here, right? So from here you can get at this point the x is 2 and your y is -1. So you just have to substitute the x with 2 and the y with -1. It's much more easier. You directly evaluate this whole thing here. So plus 2x, your x will be 2 dy dx plus with 2 times with -1, everything equals to 0. I can directly substitute all the value of x and y into the differential equation here. So x2, y is -2, and 2 times 2, your x, and your y is -1. So I evaluate now. So I see that here you have -2 dy dx, right? -2 dy dx plus with 2, 4 dy dx, right? So equals to, as from here you have 4 to 8, right? You have 8 here, and here you have -2, right? So 8 minus 2, you have +6. From here you get +6. The +6 you move to that side, you have -6, right? -6. So -2 plus 4 dy dx, -2 plus 4, you have 2 dy dx, right? So you have 2 dy dx equals to -6. So therefore your dy dx will be -6 divided by 2, -3. So we can conclude that the gradient of the curve at point 2, -1 is the gradient here refer to dy dx, which is -3, right? That's the way you answer this question. It's the gradient of tangent at this particular point. Alright, that's all for this question.